because they have this air of authenticity, they tend to be believed. And so I think the danger is that we just sort of consume passively these maps and we just accept them by and large. And same with students. Oh, okay, that's where Argentina is because Channel 11, wherever this happens to be, said so. Well, oops, no. So I think that another advantage of using geospatial technologies is it's part of your overall effort to teach other concepts beyond geotechnologies, namely data quality, working with data, how to use it, how to work with it, how to make decisions, how to ask good questions, all of that sort of thing. This is all part of, I think it's fundamental. So I've got a whole presentation that I can share with you sometime on bad maps. I'll just show a few of them here. One of the worst offenders is these maps that are by state, favorite food or favorite sports team or the occupation that makes the most money. They're not scientific. They don't give you an end value, right? So here, Texas, the favorite food, stuffed avocado. I don't even know what that is. How many people did they survey? Hey, do you like avocados? Are you from Texas? We'll put that down on our map, right? They're just eye candy. They're just meant to get people upset or engaged or to click on something, right? So there are a lot of very bad maps out there, this being one of the series that I dislike the most. Here's another one of those continental drift ones. Oops, this one, Hong Kong migrated all the way over from Asia to Brazil. Yep, you got it, you got it. Now, I know that it gets hot in Texas, but look at this. I know it probably felt like it yesterday when you guys were out in the field, but so sometimes it's not even map data, it's actually the data feeds that come from, for example, real-time, in this case, a real-time weather feed. This was online for about a year, and so I finally decided I better take a screenshot before someone fixes it. And look at this, 3,276 degrees, but it feels like 3,277 degrees. And look at I know it's windy in Texas, but look, gusts from 255 miles per hour. That's pretty hot and windy. And look at the humidity. It's 200, and the precipitation rate is 655, I don't know, inches per hour. That's a major flood, a major windstorm, and a major heat wave all at once. It's like mercury. Yeah, okay. Another one, though, is some of these consumer-facing map tools like Google Maps. If you pan over on Google Maps into China, you'll see that the distance between the streets and the image is offset. Try it sometime. Right now, at the time that I took this screenshot and measured the distance offset, it was about 1,800 feet off. So you see that bridge over the river? It's offset from the image. Now that's intentionally done by the Google servers in China for what they say national security reasons. They don't want people to be able to have super accurate maps. So you just have to be critical consumers of data, right? Including map data. One more for you. We can make all kinds of maps this is actually from ArcGIS Online, and it shows population growth and decline, but not as a choropleth map. In other words, not a map that has a single tone or a tint per census tract or block group or county like we looked at yesterday. This one is by dot, one dot equals X number of people. In this case, the red areas are losing population and the green areas are growing. However, because of these algorithms that the dot density map uses, it puts the dots in random pattern in the neighborhood. And so if there's a lake or a reservoir, as you see right here, it looks like, if students took this literally, that people are actually living in the reservoir. Now, I know there are houseboats around the world that people actually live on, but that's not the case here. Okay? So I love the capability of making different kinds of maps, showing different kinds of data and patterns, but we just need to be instilling that whole theme of let's know where the data came from. So for example, remember that migration map that we looked at for maybe 5 or 10 minutes, where you've got those lines of yellow indicating where people moved from and where they moved to by country? I love that map. But remember that first section of it, we said, where did that map come from? It came from the UN Department of Economic and Social Affairs, their world migration data. Not perfect, very useful, not perfect. There are significant limitations of it, as we talked about briefly, but the idea of knowing where that data came from, I think, is really important. So in every one of these lessons, we've been saying, according to this data set, we can see these patterns. So I think that's something to work into the vocabulary when you're teaching these things. According to what we're looking at here, this seems to be the case. Might want to look at other sources, just like when you're writing a paper, well, like when students are writing a paper, right? Gather different sources. All right, all that is to say that we had several themes running through the workshop yesterday, data quality and knowing your sources being one of them, right, folks? Folks, I just once again salute you. Here you are on a Saturday. You could be out hiking around and doing chores at home and stuff like that, but you've chosen to be here, and I really must salute you. This is, I think, a very good thing to be doing in education for all the reasons we talked about yesterday. Problem solving, critical thinking, inquiry, real world investigations, engaged learning, right? I had one of those golden moments in a middle school not too long ago where we were looking at population change. And one of the students says, I'm going to go, this was in Metro Denver, I'm going to go down to my grandma's house in New Mexico and look at the language spoken at home, population change, and a couple of other variables. And some other students said, oh, I'm going to do that too, where I went on vacation last year or whatever. And so it was one of those things where it wasn't part of the lesson, but they were all engaged, they were all investigating, they were asking questions, they were comparing each other's results. And so I just kind of sat back, it's one of those golden moments as an educator, right? Where you're just kind of beaming and people are just engaged and they're not goofing around, they're actually focused, but they weren't all doing exactly the same thing at that point. Nice. Okay, I'm going to stop the video just to save on the bandwidth. But one of the things that Dr. Ontiveros and Dr. Mubako and I have been discussing is showing you a couple of examples of what students actually do with this. Now, folks, it's all good that you're in this workshop and we're all having this sort of geo moment. Do I need to break out my guitar? We could sing some John Denver songs. Some of you were born after John Denver, so you're like, who's John Denver? Anyway, the point is that we've had this moment in these 2 days, and we're going to continue our relationship, right? We're not going to say at the end of the day, well, buena suerte, good luck, see you later. No, we're going to keep in contact with each other, right? We're going to keep moving on this journey together. However, I know a lot of educators that know a lot about geographic information technology, and that's great. But some of them do not give it to the students. They know a lot, but they don't let the students fly with this. And so my deep admonition, encouragement to you all is, please let the students work with this, okay? Now, I know that some of you are teaching elementary, and we talked about the model of, showing this on a screen and with a projector. That's fine, but have them do a little bit, even if you've got a couple of, Chromebooks in your classroom or a couple of iPads or, some laptops on a cart that you can borrow from time to time. Let the students do something with this. Okay. And that said, there are some educators that I wanted to highlight here. I have a bit of mixed feeling about the first one because even though I love what they're doing, I don't want you to think I've got to do that. First of all, the topics may be different from the topics that you're teaching. And secondly, this first one that I'm going to show, which is actually out on the link for today, which is day 2, the Hans B's Montana Student Story Maps. We're going to talk about story maps in a bit. But Hans has been working with students for several years with this, okay? So I don't want you to think I've got to go to the deep end of the pool right away and I've only been doing this for 48 hours. So don't, but don't get too stressed about, oh, I want my students to do that. For one thing, you might not have time in the field. A lot of these projects that these students work on are field-based. So all that is to say, please take this with, those comments in mind. Now, Hans has got a very nice, he's got it on Weebly. He's got a Weebly page of some of his student projects. This is Big Fork Schools. It's up in Montana, up in Big Sky Country, and he's got this nice web map gallery that's public facing, so you and I can look at this. So you can do the same thing here in the next few minutes that I'm doing. You don't need to follow along exactly what I'm doing, but it is on day 2, Hans B's Montana Student Story Maps. If you pull up that outline for our workshop, folks, you'll see it, and you can feel free to do this on your own. I'm just going to highlight 2 things there. One of them is directly related to what we looked at yesterday. Remember when we looked at the Change Matters viewer, and we looked at the RLC, we looked at Mount St. Helens, and then we looked at El Paso, right? So that is, remember, there were Landsat satellite scenes from all over the world looking at physical changes and then human-caused changes on the landscape over time. And we talked about, yes, you can actually set one of those up where you're looking at 3 different themes or 3 different time periods. So that's what Hans had his students make, is they actually went out into this place called Mud Lake and they measured depth. And they made a triplicate map showing, as you can see here, shaded depth, vegetation community, and the vegetation class. And they also have a nice legend in each one of these. So you can see they put it on the back of on the front of a satellite image. So it's the result of their student work and so on. And they've got some nice text below it that tells you a little bit more of what they did. So that's one of the ones that I wanted to show. Another one that I wanted to show is a hiking area and site that's another student made. So this is just, again, in ArcGIS Online, this particular student put some layers in it, user-created trails, user-created fire rings. So they were doing some trail restoration, and they decided to actually map some of the things that they were doing. So this is just, again, on a satellite image base, and it's in ArcGIS Online, and it uses a web mapping application. We're going to talk about web mapping applications in a bit, which is kind of a big phrase. Don't get the terms don't stress too much about the terms, but one of the pieces of a web mapping application is called a story map. One of the types of web mapping applications is a story map, and we're going to actually build one of those this morning. Okay, so that is a couple of maps from Hans. In my Twitter post from yesterday, which I'm sure you read faithfully, ha ha ha. No. Anyway, one of my tweets yesterday was a student map from Canada, So this student was one of our winners. So again, don't stress about this. This student actually won the K-12 competition in Canada. So from time to time, we have a Storymaps competition, and we also have them in the US. But in Canada, they ran one, and again, this is the deep end of the pool. The students had been using this, the teacher had been using this for a while, and so this particular one map actually won the competition. So again, it's one of the stellar examples. Start small, start simple. Don't think you have to go here right away. But I like what the student did. So the point, as you can see here, these things called right whales. And so the student looked at the Gulf of St. Lawrence. So see the first frame in there was a photo that the student got permission to use. So again, get permission, know where you can use things, where you can't use things. So the first is a photo. The second one is a web map, right? And you know how to make these web maps. You know how to pull them up. So the student actually had mapped whale deaths in the Gulf of St. Lawrence, just east of New Brunswick. Here's Quebec, Newfoundland, etc. So it's a very nice story of it's a grim story. It's sad, but actually there's some encouraging things at the end of it. So here's just a static map. The students just had a PDF and put that in their story map. So not all the maps need to be live maps, like interactive maps like this one. Some can be photos, some can be static maps. The sky's the limit, folks. You can put lots of different things in here. Here's just a live web map, but it has a couple polygons that the student made. Just sketch them out. Like remember how we sketched the area of the eruption in Hawaii? We just drew a box around it, and then we also measured the distance. So that's all the student did there. And then had a couple of different kinds of media, maps, photos, etc. The encouraging part at the end was, here's a diagram embedded in the story map where if these whales are getting caught in these ropes, let's have a lobster buoy, the things that catch lobsters, or lobsters as they call them in the East Coast, right? I'm from a landlocked state. I don't really eat that stuff, but anyway, I know people do. The point is that the student had looked at, hey, what are some of the solutions for these whale deaths? And if we had a lobster trap without a rope that actually just transmitted a signal to the ship, then there would be no ropes and there would be nothing for the whales to catch themselves on. So that's kind of an encouraging note at the end and then a conclusion. So it's kind of like a term paper or a paper that the student would write for the class. Instead of writing the term paper, they produced it as a story map. So when we get into story maps here in a moment, think about this. What if for certain assignments that you give, the deliverable from the student is actually a story map or some sort of web map instead of a traditional paper? Or you could give them a choice, paper or story map. And the story map could have a rubric, right? You could say, I want to have an introduction. I want to have some key vocabulary terms. I want to have at least one map, one photograph. You could have some techie things in there, but then come up with a conclusion. I also cite your sources. In this particular one, I would have liked to see, and this student has an image source here, National Geographic, but I would have liked to see a little bit more of where the sources came from for all of the maps and images. So you could put that in there. The nice thing about using these maps as an assessment tool, I have found, is that the students, they can present it to you and their classmates in the front of the room and invite, Q&A and dialogue. So they have a multiple purpose. It's not just, let's turn it in and my teacher looks at it, but you could actually say, no, you need to present this for 3 minutes. Give a 3-minute presentation on your topic. So just wanted to show a few of the student-produced maps. But again, these are sort of the high-end, but it's good to have a goal. It's good to have something to aim for, right, folks? All right. Now let's do the following. I'd like to get you into this particular zone right here, and that is to make your own story map. Now, story maps are multimedia web maps, as you can see. They're very much related to what we did yesterday. In fact, we looked at a couple story maps yesterday. Remember that UAV drone Kilauea story map that we looked at the end of the day that I was all misty-eyed about because it was so amazing? It had that 360-degree image that you could manipulate for about 15 points. That was a story map. We looked at a couple of others as the day went on yesterday, okay? But I'd like to go back to our workshop outline, and then there is a designing story maps activity. I'm going to show a few slides at the beginning, and then I'm going to turn you loose and have you make one of these. But as an intro, let me just say this. I have a set of activities on story mapping that is vastly more than we could cover today. But know that it's out there, so if you want to dig deeper, there are a whole set of activities in here. For example, that map that we just looked at, these whales, this is called a map journal. It has a series of buttons on the left side, or you could put them on the right side, where you manipulate, you navigate through the map based on these buttons on the left or the right. okay? That's a map journal. We won't actually get to a map journal today, but we will build a map tour, kind of a story map. If you want to learn how to build a map journal, you could go to this set of activities that I'm going to start with right here, okay? So, story maps, they are simple web maps. They're applications really that combine, as you saw, multimedia content, audio, video, etc., to tell a story about your community, your region, your state, your world. They are actually up in this cloud-based environment, just like everything else we've been doing. So that has a bit of implications technically for how you build these. So for example, if you have 5 photographs of, I don't know, a riparian zone in El Paso that you're really passionate about, like maybe the city's planning a trail along that riparian zone for a certain stretch of terrain, and you want to take photographs of it. Well, your photos have to be on the cloud for the story map to work. They can't point to your local drive. Does that make sense? Right? If they're sitting up there in this cloud-based environment, I don't know why I'm gesturing. I stopped the video. If it's up in this cloud-based environment, it cannot be on your local machine. So all of the content has to be online. Okay, good. And these story maps, you can pull them up on your phone. You could pull them up on a tablet. You could pull them up on a laptop. So they're optimized, like a lot of different tools are nowadays, for, oh, you've only got a screen this big. Let me show you what the story map is going to look like on that size of a screen. Okay. There are hundreds of thousands of story maps out there. I think the reason why is because they are very easy to make and they are very compelling. You know, maps have been used to tell stories for thousands of years, right? Going back to the Babylonian clay tablet of 6,000 BC. They go way back. And maps were on clay, they were on wood, they were on papyrus, right? Film, copper plates, and now digitally. So maps have always been used to tell stories, and story maps kind of take advantage of that whole maps being compelling, lots of content, small amount of space. It's the story of a lovely web map. Okay, you guys with me? Okay, let me just show a couple of these. Here is a story map from the San Luis Obispo, California Police Department. Why did they use a story map? Because they wanted to introduce the community to their officers. Look, here are the officers protecting your community. Here are the different neighborhoods that the officers patrol. And these are real people, they have real families, etc. So it was a nice way for them to actually introduce the community to their police force. So they used what we're going to use in a moment. They used a map tour. So each one of these officers has a picture and it is linked to their particular neighborhood. The map journal is like the whale one that the student had made up in Canada. So this one is one of my favorites that I often use in teaching, the age of humans, the Anthropocene. So it talks about water, energy, population pressure on ecoregions and so on. So this is a map journal. Here is a map series, so named because there are tabs across the top of the map. So in this case, it's landforms, geology, forest type, fire potential. So that is presented as a tabbed story map. All of these maps that I'm showing, by the way, are publicly available, so you could actually teach with them, and as we'll explore in a moment. There's loads of maps that you can just use to teach with, but you can also create your own, which is what we're going to do in our hands-on activity. This one is an example of, remember how we used a swipe map yesterday where we had that little squeegee that went across the map? This is kind of like that. It's called the Spyglass. So you're looking through one layer into another layer. So this is as you can see, San Francisco, you could do this for El Paso too, looking at different ages and different neighborhoods and what they looked like 50 or 100 years ago. Very compelling way to do it. This one's called a Shortlist. So named because the little thumbnail images that you see on the left side, they're scale sensitive. So if I zoom in, you only see the photographs on the left for where the map extent is shown. So this one obviously is California colleges and universities, but this could be different plants in El Paso, different kind of shrubs in your desert environment. You know, this is what a cholla looks like. This is what a prickly pear looks like, etc. Okay, this is what a cottonwood looks like, and so on. So that could be plants. It could be cloud types. It could be different kinds of trash. Well, it's El Paso. There's no trash, right? You've got a beautiful environment there. Anyway, the point is, if they're doing a trash survey, here's the glass type of trash. Here's a garden kind of a trash. You know, bio matter. This is paper kind of trash. This is aluminum kind of trash. So they could do a trash survey. This one is called a Cascade story map. This one is about, I've used this quite a bit in teaching. This is this one's called the Uprooted. It's about the Syrian refugee issue. And so there are some 2D and 3D maps in this particular one. The Cascade is so named because, like a lot of web pages nowadays, you know how you scroll through it and it sort of cascades from bottom to top as you move through it. That's what these Cascades ones do. There's also something called the Crowdsource one. So if you set up a Crowdsource map, you can invite your students, and your students can invite their peers to say, hey, I'm conducting a survey on plants on campus, or pedestrian counts. What's the busiest intersections in El Paso, or different cool places to go in the city. And I want you to contribute. So it allows people to input a photograph and a short description. So it's truly a citizen science kind of a story map. Very nice. So I'd like you folks to go to this web page right here. And let's go ahead and fire up the Storymaps gallery, because I'd like you to just spend a few minutes looking at the different story maps that are out there. Pick something that is of interest to you, and I will gather you back together in a few minutes and have you report out about what you found that maybe is of interest, or maybe that you'd actually teach with. And you can browse by the different types of story maps like we looked at in a moment ago, or by subject, environment, culture, etc., history. And so go ahead and do that, please, and we'll chat in a moment. Any questions so far? Sorry, let me bump up the volume on my phone. What was that?
There's a lot of books out there on ArcGIS. Is there a book that you would recommend for us to continue our learning after this course?
Yes. Let me pull that up in a separate tab right here. Good idea. All right, while you folks are largely examining the Storymaps gallery, let me just address that question. I think it's a good one. There are indeed a lot of books to learn more about GIS. For K-12 instructors, I think most of those books are, I'm going to actually teach GIS in a GIS course. I think most of you, if not all of you, are actually using GIS in history, art, math, STEM, biology, geography, etc., right? That said, most of those books are really on the technical side, like I want to learn how to geocode a bunch of addresses, or I want to learn to do X, Y, and Z. And so that's not a bad thing, but just realize that they're more on the, I want to learn these tools. I think one of the best books, especially for educators, is a book that two of my education colleagues wrote. So they are former middle school and high school teacher turned, you know, like all of us, right? We don't really retire. We just keep pursuing additional cool things to do, right? Like most teachers, you don't just go out into the natural environment and just hang out. You're probably going to be pretty active in some ways. So same with these two teachers. They retired from the classroom and now they are basically consultants to help educators learn more about geotechnologies. And one of the things that they did was they wrote this instructional guide to the ArcGIS book. It's 10 activities and 10 lessons. I would highly recommend this as if you truly want a book. I'm not sure the book is the best way to go, but if you do want a book, I think this is what I would say for the top recommendation. It's from Esri Press. You could probably get it for less on Amazon. I think we have it in digital form from Esri Press, which of course would be probably ideal because then you can click on things and pull up those maps. I hope that helps. Ooh. Yeah, so yeah. So Dr. O is saying, hey, how do we get something submitted to this? So I think it touches on one thing, and that is this is just a subset of all the story maps that are actually out there. As you may have seen from that graph that I showed a bit ago, there are over 500,000 story maps, and there are obviously not 500,000 in these pages. There's a couple hundred. And also this rotates, right? So in 6 months, the World Cup is not going to be on, well, even in 2 months, the World Cup is not going to be listed on the top of this. So it's a rotating gallery, but you can always find these by searching for a set of keywords in the upper left of the gallery. Now, I would love to, building on what Dr. O is saying, have some more student work in here. There are a few, but I'd love to have your students work in here at some point. If you scroll down past the collections on the left side, it says, hey, want to see your story map featured in this gallery, as I'm showing right here. Submit your app. So there is a way for you or anyone to submit your story maps to the folks behind the gallery. So yes. Oh yes. Yeah. So, you know, it's one of those things where tell a compelling story, make sure you document your sources. Now, there's nothing to prevent you and your students from making your maps public. It doesn't have to be in the gallery. We'll talk more about how to make them public when we make one, okay? So you can make one and then link to it, write an article about it, you know, blog about it, write a tweet about it, etc. So there are ways to make it public. It doesn't have to be in the gallery. The gallery is, again, it's good to have goals. It's good to have aims. I've had one of my maps in the gallery over the last 5 years. So it's pretty difficult to get in there, but I'd love to have more student work in there for sure. Yes. True, not in the gallery. Anybody can publish one, but just being in the gallery it's kind of like a conference. You know, you've got so many slots. You've got a very small staff looking at these, and so those are the main constraints. Also, yeah, as you folks are browsing around in there, since we are going to make a map tour, I'm going to click on the left side there and go to map tour, and these are all of the map tours in the gallery. So they all have the same sort of look and feel. If you click on map tour, you'll see the different styles. One of my favorites is from my colleague, Dawn Wright. She's our chief scientist at Esri, and she likes to make these map tours showing where she's been over the last year and how she's promoted science and GIS around the world. So these are some of her places she went last year and the year before to promote this in science. So as you can see, there's a string of thumbnail images on the left side and on the bottom. and it shows where she went. So that's pretty cool that we've got a chief scientist. She's actually an oceanographer, geographer. So combining the best of both worlds there. I also wanted to, and that's right here, ask you folks, hey, have you found a map that you either find really compelling or that you actually might be able to teach with? Anybody want to volunteer and share? Ooh, tell us about it. Ooh, where are the bodies? Bum, 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 bum. This is a map journal. So it's what I would consider sort of a level 2, but really interesting. We get a fair amount of press on this at around Halloween, just because of the themes and some of the people that were in this story map. But anyway, very interesting. What if, taking that idea, what if you had a cemetery survey and highlighted some of the famous people that are buried in, in and around El Paso? I know some middle school educator up in Idaho that really his focus is having his students go out and mapping headstones and determining how old all the people were and how young. And so there's a little bit of a math integration there, and they compute the mean of the ages from different decades and showing how there was a lot of infant mortality in the past and so on. I'm going to ask just one more person, if you don't mind, to share. Uh-huh. I love the creative energy flowing around the room right now. Now, again, like I was saying yesterday, put your teacher hats on. I know that you can't take them off. It's part of who you are. But think about, how would you actually introduce the idea of story maps to your students? One of the ways is by starting with this gallery. That's one of the reasons why I wanted to show you this first. Get them thinking about telling stories with maps and the different variety that's there. There's a whole wide variety. The nice thing about the gallery also is that it's, as we talked about a moment ago with Dr. O, they're all vetted. There's nothing offensive, so you're safe by going to the gallery, okay? One more thing. I'm going to show you a couple of maps in here, and then we're going to actually build one, okay? Yes. Sure. Yeah, I was going to go into this when we actually create one, but we might as well mention it now. Good idea. So we have been working with these cloud-based tools, and we've been largely using maps and data that other people have published. And as we move forward, we're going to be creating more and more maps that you and your students create. The nice thing about the ArcGIS platform, folks, is that you have this, hope you can see this little gesturing motion, this range of how you can share. On this side, it's sharing with everyone. Anybody can look at it. That said, in order for someone to actually find it, as you probably have sensed, like, let's take a look at this Chief Scientist map tour. You see this big long alphanumeric string on the end of it? That's called the map ID. Unless this was in a gallery or tweeted about or blogged about or put in an email link, the odds of someone actually finding it are very, very small. You can't do a Google search on most of these and just find them. So even if you make it public, it's sort of hidden unless you let people know about it. So let's say you're working on a map and you temporarily make it public so you can share it with some people. So you really don't want the whole population of the world to be potentially looking at this. Don't stress, because they're not going to find it unless you tell them about it, unless you, again, blog about it, tweet about it, somehow get it out there in the public sphere. But this side is, I'm going to make a map and I'm going to share it with everyone. Over here, I'm going to create my map and I'm not going to share it with anyone. No one else can look at it except me. They have to be logged in as me to look at it. But right in the middle here, there's this wide range of potentials. And without going into too much detail, but let's say you've got an ArcGIS Online organizational account at your school. It is just your school. Your students can publish into that account, into your school account. If they share it, they have a couple options, and let me just detail two of them. One, they can share it with a group inside your school account. So let's say it's your Biology 101 students or your 8th grade geography class. You know, that can be a group. Think of, this isn't a perfect analogy, but think of like a Facebook group that you have to be invited into, right? You can't look at it unless you're in that group. So you can set up a group and it may have 5 students and you in it, may have 10 students, it may have 75 students, but it's only with that group. Or they can share it with your whole organization, which is basically your school. So anybody that's in your school account can actually look at it, okay? And that's fine too. You might take a certain subset of those and make them into a public-facing, here's 5 really neat maps that our students made, and you show that at parent-teacher night, or you put that on your school webpage or something like that. So you could take a subset and make those public, making sure that you remove any sort of authoring information like Dr. M is referring to, so that nobody can, if you don't want, so no one can find out who the author is. You can remove all that. So there's lots of possibilities here, folks. Not everything you make has to be shared with the public, okay? I hope that helps. Yep. I'm going to look at 2 story maps with you all. Does anybody else have one that I know you've looked at these extensively yesterday, so we don't have to belabor this, but I want to show 2 of these. One has to do with a place in Texas. So I was at Texas State, a couple 100 miles east of you, not too long ago. And on my way to the airport, because, you know, I'm a geographer and everything is sort of on the way to anything else, even if it's totally in the opposite direction, I went to Wimberley. I'd never been there. It's up in the hill country. Anybody been there? Okay, they had some massive floods a couple years ago there too, so it kind of made the news. You know, they're in sort of disaster central there. It's either, it seems like there's either wildfire burning or there's a big flood or there's a big drought. Anyway, one of the things that I discovered there was these series of wonderful boots. Each one of these is about 10 feet high, and it's a public art project. I looked on the Wimberley Boots public art webpage, and they had this horrible map. So I thought, I'll make a story map showing people how to take a tour of these boots. And each one of these boots has a story behind it. One of them is birds of Texas. One of them is the history of Texas. One of them is landforms of Texas, etc. Okay, so I put it together into a story map, as you can see here, where I describe that it began in 2014, blah, 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 why boots? And then I have a map of Texas here of historical sites in Texas. Okay, learn about the geography and history of Texas. And then I have a third panel about how I made this. And then here's my 4th panel, which I encourage students to do. giving credit where it's due, and links to learn more. These are all my photographs. So in the case of the photographs, I did not have to get permission from anyone. And then a tour of some of my favorites. I've got a video and so on. Okay, so that is my Wimberley, Texas boots. I made that shared with the general public so you could actually look for it. You can look on the Storymaps main page and find my Wimberley boots. These boots are made for walking. All right, folks. So you may wonder, how did Joseph get this yellow outline? How many of you use a fitness app like Runkeeper, Map My Run? So it's a very motivational thing, isn't it? Ooh, if I go around the block one more time, I'll get 0.2 more miles, right? So I just took my track from that day's walk around the city and uploaded it into ArcGIS Online. So that's where I got the yellow line. Yep. And then the photographs, how does it know where the photographs are actually taken? Oh, you folks are good. Ustedes. Yep. So I had the location-based services turned on my phone. And so I have the photographs as an app that is linked to, okay, I'm going to use the location for the photographs. So it's going to record the latitude, longitude, right, of every one of my photos. So that way, when I put those photos into my map, it knows exactly where the photographs were taken, give or take a few meters. Now, if you're in a canyon or in a heavily forested area or in downtown Houston where there's a lot of tall buildings and you have not very much GPS signal or cell phone towers or Wi-Fi hotspots to triangulate off of, your position may be 10 meters off. It may be 20 meters off. So it's a good data quality check. You can move the position if they're not exactly where you want them to be. So just wanted to mention that. So there's my Wimberley boots map. It's pretty simple, but it's one I wanted to show because I've got a video in there and so on and so forth. Let me show you one more, and that is on the gallery. If I, yep, it did. It was kind of short-lived, as you know, but it was one of those sort of harbingers of the future where there's going to be a lot more geo-based games in the future, and some of these developers, they want to be able to have a live web mapping service to put behind their game. And some of them use the Google API, the application programming interface. Some of them use the ArcGIS API. They all have their advantages. But yeah, some of them actually use ours. And I just wanted to mention that we do work a little bit with the gaming community. Not much, because we have, just like you all, limited staff, but we do make that interface open to people to develop on top of. That's why we call it a platform, because you can develop other things on top of it. You bet. You folks are great. Now, I'm going to, in the search box in the gallery, type in Titanic. I've got 2 maps that show up. I'm going to click on Geography, Class, and History of the Titanic. Now, I know this is a historical, geographical sort of event, but I wanted to show it for a couple techie reasons. Yeah, I could teach about the voyage and talk about how people immigrated 100 years ago, right? They weren't flying on jets and so on. They came by ship, by and large, right? Unless they came from Mexico, in which case they were crossing on historical trail routes. So the point is that on this map, a couple techie notes. One, it's using the ocean's base map, which is available to you. And that's, if you're teaching about oceans, ocean currents, etc., this is a wonderfully rich map that you might want to use, the ocean's base map. The second thing that I wanted to point out, and we'll get into this a bit later when we go into natural hazards and earthquakes. But every one of these points is tied to a database, okay? So if you click on any one of these points, you will see, well, it's pretty grim, but whether that person lived or died. So Edward Ryan from Ireland lived because it's a light blue. Okay, John Hume from Scotland did not live. There's a person over here in Colorado where I am. Hey, does anybody know anything about this person? Yep, the unsinkable Molly Brown was her name, and because she survived, she got that nickname applied to her for the rest of her life. There's also someone from Lake Arthur, New Mexico, not too terribly far from you, James Bracken. Unfortunately, he died. Another thing that I like about this map is that it's sort of like a lot of maps, dispels preconceived notions that may be erroneous. So for example, if your students thought everybody on that ship is from the USA, the UK, or Ireland, well, that's not true. There's a lot of people from Lebanon. There were a lot of people on that ship from Scandinavia. There's some people from South Asia, not many, but some people from Hong Kong, a couple people from Australia, etc. And the reason why I like to point out this whole clicking on these points and getting information is because, remember, this is a GIS. The G part is the map. The I part is the information behind the map. So there's a database behind just about everything that we've done in the last 2 days. In other words, these aren't just a bunch of graphics floating around in cyberspace, folks. They're actually tied to what we call a geodatabase. And Dr. M at UTEP, he teaches whole courses in geodatabase design. So there is a geodatabase behind here. We'll look at it more in a bit with the earthquake data. And then finally, the last thing that I wanted to point out here is to get your students thinking about, pivotal points in history. Notice how they were following this curved route across the ocean. And then they got to this point where it was called the corner, where the ships turned. I have another lesson where I actually plotted out the warnings that the ship had received, and where this actually hit the iceberg at this big giant X. That's where all the ice warnings were. So one might think that if the ship had stayed on this Great Circle route for just a bit longer, it would have ended up right around this 5992 depth and then turned, and it would have avoided that whole ice pack, because you can see the Grand Banks south of Newfoundland, this shallow part of the ocean is where most of those icebergs were hanging out when they started drifting south. So, you know, it's one of those hindsight 2020 moments in history, but have your students think about if the ship had continued, have them maybe draw a line, even if you printed this, have them draw a line, and they would have avoided all of the ice warnings. Anyway, so that is another story map, and this is a tabbed story map, because if you pan across first class, second class, third class, you'll see the sort of the grim details of the survival rate, much less in the third class. So that graph, that pie chart on the left side changes, right, as you pan across first, second, and third class. Now this is passengers only, does not include the crew. So another discussion point with students could be, okay, knowing the class of the crew, most of them back then, right, they did not have very high status, didn't get paid very well. What do you think their survival rate was? And maybe do additional research to find out exactly what the survival rate was of the crew. Oh gosh, I think most of those most passenger ships now, you know, one of the things that happened in the last 100 years, right, was well, lots of things happened as a result of this particular sinking, as you know, but one of them was better safety, a lot more lifeboats, et cetera, et cetera. But yeah, this could be part of your lesson on, hey, do shipwrecks ever happen again? Remember that one in Italy like 5 years ago where that thing went on its side? That was pretty grim. Yep. All right, so folks, let us build one of these. Before we do, let me just list a couple of advantages of Storymaps. First of all, they're tied to what we've been doing the last few days. They're tied to ArcGIS Online, rich way to teach content, fostering critical and spatial thinking, way to assess student work, support research, skills in communication and understanding. Okay, and you can look at the rest of these slides on your own. But I'd really like to get you into, let's build one of these right now. All right, geeky photo of me with 3 points. These tools are rapidly expanding. You know, this is a dynamic tech environment, and so there will be more choices of the kinds of story maps you can make in the future. Great. But the nice thing is that every time there's an additional capability, they actually get easier to use. They get easier to create. Also, just like when you're doing anything with the students, going out in the field, planning a project, etc., plan ahead. So let's say you want to make a simple map tour kind of a story map like we're going to make. You can't change course in the middle and say, you know, I really wanted a map journal. There's no magic button that says, oh, change this into a map journal instead of a map tour. That said, you're never investing all that much time into these. I would suspect that that whale map that student made took probably numerous class periods to make, but mostly you're making something that's pretty short. As we'll see in a moment, you can make one in the span of 5 or 10 minutes. But plan ahead is a good thing to do. So we're going to make a map tour. As I pointed out yesterday, there is a lot more content in here that you are free to dip into at some point. Now, the map tour is just one of about 10 types of story maps. And remember that San Luis Obispo map with the police force? That's the kind that we're going to make right now. It's got a gallery of larger images on the left and a smaller set of thumbnails on the bottom. There's a journal, there's a short list, there's a playlist, there's a basic, there's this swipe, etc. But we're going to make a map tour right now. I'm going to go to these. I'm going to go through 5 steps with you all. And yes. Exactly. Yep. This whole thing is there. I'm going to leave this on the screen when you are working through this. But let me just, if you don't mind, let me demonstrate the steps, and then I'm going to turn you loose and have you do it. Okay? So my demonstration will be pretty brief because I want you really to actually do this. Okay? So let me just demonstrate, if you don't mind, just for a moment, and then I'm going to give you some, don't worry, I'm going to give you some time to do this. So are you good with that, folks? I'm seeing some nods. Okay, good. So I'm going to spend the next 120 seconds showing you what you're going to do over the next 10 minutes, okay? So don't stress about, I've got to memorize this, because I'm going to put up that slide that actually has the procedures when I'm done, okay? I just want to give you a sense of, here's the general workflow. So this is not the time to memorize. This is just the time to say, okay, I kind of get the idea, okay? So once I'm on this page, we went to the gallery a moment ago. Right now, I'm going to go to apps, and I'm going to say, oh, create story. Great. Pick an app. I want a map tour. So I'm going to go to the left side, map tour. And then it's going to say, okay, you want to make a story map. That means you need to log in. So this is where you're going to log into your ArcGIS Online account. And then I'm going to say, oh, I'm in what we call the builder mode. Continue to map tour builder. Great. That's what I want. So then it says, okay, where are your photographs? Remember, they cannot be on your hard drive. If you have them locally, you can put them in ArcGIS Online right here on this right side. But on this left side, I've already got mine online. And in this activity, I actually want all of you to build the exact, well, with some variation, but pretty much the same story map so that we all have success in making one. And again, putting your educator hats on, I highly advise doing this with your students, because if you just sort of say, okay, you build one now of whatever topic you want, you get into that whole, I don't know where the photographs are, do I have permission to use them, blah, 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 right? You get into this sort of sea of techie issues, and I'd really like to have them all make one that is, okay, I get it. I've made one, I can be proud of it, and then branch out from there. But that's what I'm going to do with you. I'm going to practice what I'm preaching here. My photos are already online. They're actually in Google Images, Picasa Web. So I'm going to have you actually go to my zone there where my photographs are stored. And I've got them in folders. And you're going to scroll down just like I'm doing here to this thing called the Esri Sustainable Campus. And then I'm going to import. The story that I'm going to tell is about our sustainable campus initiatives on our Redlands campus. You know, most universities have, and most campuses have some sort of sustainability initiative. It knows where all my photographs are. I'm just going to say import. And at this point, I just will tell you that the story that I'm telling is twofold. The number one part of the story is that we actually brought, with these massive pipes, non-potable water to water our 3,000 trees on campus. These are some of our trees. Our company president is a landscape architect. You can kind of tell from our structures and plants. So every rock, every tree is actually planned. And what's wrong with this picture? This is Southern California. It's just like West Texas, right? Here, I'm zooming out on the map. There's not a lot of water there. So how do we get the water to water all of these 5,000 trees on campus? Here's some teachers collecting data. Well, we do that with this new non-potable water system that brings water from a couple of settling ponds to the north of the city to the campus. The nice part about that is not just that we're saving millions of gallons of city water in a very dry environment, but another part of the story is the excess goes to the city. We give it to the city and they can keep their trees alive in their parks and then their median strips on the roads and stuff. The other part of the story is if I change the base map, there's a little gallery here. I'm going to change it to imagery with labels. If I change the base map for the campus and I zoom way in there again, the other part of the story is, as you'll be able to see here in a moment, what are these things on the roof? Yep. So almost all of the buildings have a set of solar panels. So it's the water and it's the solar panels. And then another part of the story is actually we've got a lot of bicycle parking and also underneath the building. So in case it is raining, which is very rare down there, but sometimes it is, you can actually park your bike underneath the building. So that is the story. Now there's a couple of captions, but what I'm going to do is I'm going to say water intake for campus. So you can see here, you're going to be able to put in captions. And the last thing that I want to do is go to this organize button on the left side. And here you can change the order. So if I want this big, what's called a Cereus cactus, it's actually not S, it's CEREUS. It's the oldest thing on campus. And if I wanted to have that now in number 1, see now that's in frame number 1. So depending on how you want your story, you can go to this organize and move these photos around, okay? So that's what I want you to do over the next 5-ish minutes. I'm gonna go back to the procedures and I'm gonna have you go through those procedures to get your story map built. It's right here. You guys seeing these procedures right here? Yep. So please do steps 1 through 5, and I and your colleagues will be around if you've got questions. Go forth and map. Feel free to take a break too, folks. That's because you've got a top-notch group of educators there, sir. Yep. All right, folks, greetings once again. So you've got your story map created, correct? And just to summarize, you went to Storymaps. You went to the apps place. Storymaps are really apps. It just sounds more fun to call them story maps instead of story apps, but they're really mapping applications is what they are. But you've created a story, you created a map tour, you had to log in, you had to tell the system where your images were located. Mine were all, as you saw, geolocated because I had the location-based services turned on my phone. If your photos are not in their correct location, either because you took them with a standard camera or they did not have any sort of geolocation on them, you can drag them to their correct location as you saw when you were building your map. We imported those, we added some captions, we changed the base map, we rearranged the order, so we're actually ready to save it now, unless you've already done that, which is fine. So if I'm up here in my story map right now, I haven't really done much to it other than rearrange the order and add a few captions. If I want to now save this, that would be a good thing because then I can come back to it tomorrow or the next time I want to teach with it, correct? And so there is a save up in the upper left there. It's going to save it to whatever title I have. So I'm going to call it, as I mentioned, give it some sort of a slight adjustment because if you save it as Esri Sustainable Campus, it's not such a big deal in your case, but I've got numerous copies of this. So if I call it UTEP El Paso Independent School District June 2018, then I'll know that this is the one I created today, just by the title. So I'm gonna use that title, and now when I save it, by the way, what is this symbol on many save applications online and on the desktop? Why is the save symbol a floppy disk still? Nobody even knows what a floppy disk is unless you lived in the 20th century like I did. It's just funny. So I titled it, I saved it, and then I see this box. You guys see this box? This link to my stories is actually quite helpful, and I just want to spend a moment looking at it with you. My stories is your Storymaps library of your own content. So in my case, I've got a bunch of story maps in there, okay? The most recent one I made is right here at the top. Esri Sustainable Campus, UTEP, EPISD, June 2018. Do you see your map in there? So when I went to save the map, I have this box that appears. It says, you can use my stories. If you don't see that box, I can help you get that box back. So let's say I make a small adjustment. So if I made a small adjustment, and then if I save it again, I don't see that box appear. So that might be where you are. The way to get it back would be in a new tab, go to that Storymaps page again. So just storymaps.arcgis.com. And at the top, if you are logged in, do you see where it says My Stories? That's where I want you to go. I'm going to use the Annotate tool. Cool beans. So that My Stories area. Got it? Sweet. Everybody else okay with that? Great. So in My Stories, I'm going to click in there. Let me clear that. There we go. Again, it sorts on, the default is in reverse order, so the most recent is at the top. And if I click in there for my story map that I just made, it gives me some information. It says, okay, you've got 5 images. And it, sorry? How do I go to My Stories? I'm going to ignore them right now because that is more, beyond what we want to do. Just get you successful in making a story map. We can change the HTTP to HTTPS later, but I really don't want to go. I'm just going to ignore them. Yep. Good. So this tells you some basic information about where these are located, if they all work, and you can also edit the map behind the story map. In other words, remember how in Wimberley Boots, I added my track from my fitness app on my phone? So I did it by editing the map behind the story map. So this is where you would do that. See, it's got images, and if you click on maps to the left of images, this is where you would actually be able to edit the map behind the image. Another thing you might want to do is pay attention to this little thumbnail. You can change the thumbnail image if you want a nice picture of in this case, a cactus or a tree or a shrub or something like that. Instead of that default, you can do that. But more importantly, notice that it's not shared with anyone, right? It's private. It depends on the issue. If the issue is that it can't display an image, like let's say you're trying to point to a photograph that's on your Facebook post, or some other place that's you have to log in to see, it won't display it, and so that won't show in your story map. You can still publish the story map, but your users will see a broken link right there. So it depends on the issue. In this case, we can ignore the security on the images for now. We'll go back and fix it maybe later if we have time, but it'll still publish and it'll still work. So it depends on the issue. But the nice thing about the story maps, My Story zone is that it checks it for you. And so right underneath the thumbnail, as we were talking about, right now it's private. If I wanted to share it with my organization, what is my organization? Exactly. So it will be just like you said, when you are using your school account, your organization is actually your school. Yep. And then on public, that is, then anybody in the public could see it with the caveat or caveats that I talked about earlier. Nobody's going to be able to find it unless you tell them about it in a blog or a tweet or something like that. Okay, so that's all I wanted to point out, is that this My Story zone is a good way for you to manage your story maps. Yep. You can also preview what it's going to look like when you publish it, et cetera, et cetera. So it's a nice place to go. You might want to put a summary in there so that you can use some keywords to find it later on more easily. But that is pretty much all I wanted to show you there. No worries. You know, on a techie note related to collaboration, this is not something I usually mention in the first 2 days, but since you folks are the top-notch teachers that you are, there is a way to collaborate on a technical side too, and that is, what if your students were posting to content that's up in like a Google Drive, like a document, a spreadsheet, and they're all contributing to that spreadsheet, and the map is pointing to the spreadsheet. So that means there is the capability of having your students collaborate because they're all editing that Google spreadsheet, let's say. I've got a set of procedures written on that if you're interested. So just keep that in mind.
Okay, thanks. We have noted that. So I think let's move on. I think they are ready.
Very cool. Now I did a preview of my story map, so I haven't added that much to it, but I've changed the base map. So that's what I'm looking at right now, is I'm previewing my story map right now to see what it would look like when I'm not actually editing it. And you know, I'm pretty pleased with that. I would need to add some more captions, but you can see that it's pretty easy to make one of these. Excellent. So that is a map tour, and you folks should be proud because you made a map tour. Ustedes. Okay, very good. Cool. So now we've got more to do, but let me check in with you. Did everybody have a break?
Some of them didn't. They were just matching and matching and matching.
All right. Well, I don't want anybody to collapse.
Yes, and I think we also want you to give a break there. You suggest the talk. What are you suggesting?
Well, I don't know what the condition is of folks in the room. We've got 2 more short activities. We could have a break and then do the short activities, or we could do one activity and then have a break and then do the final activity, the one with me anyway. Whatever you say, you're the boss.
Yeah, I think we should look okay. Let's take a short coffee break, and then we come back for your remaining 2 activities.
Excelente.
How about that? Okay. So 10 minutes, 15, how much you want?
I think 10 is fine, but again, I don't want to be the mean guy.
Yeah, okay, I understand. I think about you guys are getting used to the queue. Okay, I think
we're ready for you.
Okay, You're seeing that video that I'm showing? Cool. That's just an idea planter. Things that you could do that we won't have time to touch on, but there's a couple of things in there that we're going to do here in this next segment, and that is we're going to make a map presentation and look at plate tectonics. But again, think outside the box like we talked about yesterday, folks. You may be not excited or teaching about plate tectonics, but think of this as some skill building that these are just points, lines, and polygons sitting in a map. It could be any kind of data. It doesn't have to be earthquakes. It could be cities. It could be water wells. It could be, again, plants on your campus, etc. Okay? So don't get too locked into, I've got to teach this content. It's mostly proof of concept that you can build your own and look at your own data that's of interest to you with these same tools. Muy bien. Well, welcome back. Bienvenidos. All right, it's all good. I am going to the outline for our plan. We are firmly anchored in this middle section in day 2 right now, and we've made some story maps. We've looked at a few more, and hopefully that is of interest. Some educators start with story maps. Some start with the geo-inquiries. Some start with the Living Atlas of the World, which my colleagues will talk about later. There's no single pathway, you know what I mean? You are presented here in these 2 days with an array of things that you could do, and there's no one right way to do it. Some educators I know start with the story maps that we just did, and they love those. And that's great, but I also tell them there is a whole platform behind this. So 5 years from now, don't just be doing story maps. And in this next section, we'll introduce you to a little bit of analysis. Okay, another way of presenting your content, though, is something that we wanted to spend a good 10 minutes on right here. And if you go down to number 35, practical exercise 19, examine web app on ecoregions, population density, and imagery. So go to the outline and go ahead and click on that. You'll see a web map with a couple layers in it. Let me know if I'm going too fast. Yep. And let me just have a geo moment with you all. This is, to me, why this is amazing. You're all on your own devices, and it's actually working. Isn't that great? It's a beautiful thing. So as long as you've got the bandwidth, like you've got in Dr. O's school there, you know, again, there's no limit to what you can do. And that's one of the reasons why I love the whole idea of doing this online these days. So as you know from yesterday's work, have you got that ecoregions and population density map up? I'm not sure if you touched on this when I wasn't with you yesterday, but you may recall, or this may be new, but if you go to bookmarks, these are like bookmarks on the web, but instead of bookmarking web pages like you're used to, this bookmarks locations around the planet or around your community or around your state or around your region. So you can set bookmarks that you won't have to pan over to Kazakhstan or Chihuahua or wherever you're interested in looking at. You can set these bookmarks up so that if you go to bookmarks to the upper right of the map and you scroll all the way down to India and Nepal, you're going to be zoomed right into India and Nepal. So this is population density, as you can see, with the darker colors being more, the lighter colors being less. And another nice math link is, what is density? Per square mile, per square kilometer, whatever the units are, what is the concept of density? And so you can see that you've got a big range of density across this particular piece of terrain. Now, it would be helpful, wouldn't it, to go to base map and maybe change the base map to something like terrain with labels. Let's try that. Change the base map to terrain with labels. And now you see the country outlines, a few cities, and so on. Because again, I'm thinking about, hey, you've got students that are 11 years old or 14 years old. They don't know where this is around the planet. So if we change it to terrain with labels, now we see, oh, okay, it's Nepal, it's northern India. Now you may need to start with a zoomed out minute or two where you say, okay, here's Asia, here's South Asia, this is the northern part of India, etc. So notice how dense the population is, densely settled in this area south of this big mountain range. What is this big mountain range in here? If I turn off all the layers and I just have terrain with labels, what is that? Okay. And so north of the Himalayas, the population density is very low, isn't it? South of the Himalayas, it's very high. Part of the story is there are different ecoregions. So if I turn on the ecoregions layer and I click in the one to the north of the Himalayas, this is called a pop-up, and you can configure the pop-ups to whatever information you want. Remember, this is a geodatabase, so there's information behind every one of these map layers that we're looking at over these 2 days. So if I click on the one north of the Himalayas, what is it? Okay, extreme continental desert. Does that sound like a place where a lot of people want to live? I mean, I'm thinking about you elementary school teachers, how you would introduce this. Hey, what's the ecoregion around? They'll need to know what an ecoregion is, right? So you can talk about it in terms of, here's an area of similar climate, similar vegetation, similar plant life, animal life. That is an ecoregion, right? So the West Texas, northern Mexico ecoregion, it's pretty dry, right? You've got a certain kind of plants, you got a certain kind of animals that live there, and so on. So it's very different from East Texas, right? If you go east of Houston, it's radically different from West Texas. So I'm thinking about you elementary teachers. You could ask students, okay, extreme, what do you mean by extreme? So you might need to explain what extreme is, and then show them some pictures of what a extreme continental desert ecoregion looks like. And then come back to, does that sound like a place where a lot of people want to live? Maybe not. And also think about the kind of food they could grow or the kind of climate they would live in, right? It's pretty harsh and forbidding, right? This is to the Tibetan Plateau. It's pretty high, it's pretty dry, and just north of that is the Gobi Desert. Yep. So not very many people live there. South of the Himalayas, though, where a lot of those people are living, if you zoom in there and click on the ecoregion, you've got moderately humid, grassy savannas. It depends on where you click, of course. Eastern oceanic, constantly humid forests. So you've got some trees, you've got some place to grow plants, etc. So more people live there. There's also, of course, this massive river that flows through there, the Ganges. So a zone of historical settlement dating back thousands and thousands of years. So let's say we want to tell a story about that. And so you could teach with this map with the two different layers in it. And one of the questions you could pose is, okay, knowing the population density and knowing the ecoregions, write a small report that indicates, in your view, which ecoregions are most endangered by high population pressure. And cite a few examples around the world that supports your conclusion. That might be more of a upper middle school, high school activity, right? Yep. But extending on what we did before the break with the story maps, there's another way that you can present the information, or your students could present the information, and that is with a presentation. So let's build that in these next few moments together, if you don't mind. So in order to do that, we actually have to be logged in so we can create that presentation. Now, right now in my map, I am not logged in, correct? If I look in the upper right here, it says sign in, which means I'm not logged in, correct? Yep. Are you folks logged in? Cool beans. I'm not, so I need to do that. Now it's telling me, hey, Joseph, there's some unsaved changes. In other words, I've zoomed in, I've turned on a couple layers that I didn't have turned on before. If you don't save your map first, do I want to save my map? Yes, I want to save my map. And I'm going to call it very similar to what was named before. This is a map I actually made a while back, but I'm going to call it UTEP El Paso Independent School District, June 2018, just kind of like I did with my story map that I made earlier. So save it. As you're saving it, let me ask you this. This to me is a very interesting concept. In other words, I made this map. You're now saving it in your organization. That's pretty amazing. You're not changing my map, you're making a copy of it, and then you can change your copy, right? Okay, just wanted to make sure you understood that. You're not altering my original. So the cool thing for education is that, let's say you as a teacher, you create a map, your students go in there, they modify your map, and they add their own information to it, or they do it in groups. So I'm going to save this map. It's going to be now inside my own organization, and now I can modify it. What do I mean by modify? I could add soils. I could add major cities. I could add, I don't know, typhoons in South Asia, depending on my intent for the lesson. Okay. But all I want to do with you all in the next few minutes is actually build a presentation. Do you see this up here in the upper right? Okay. Create presentation. Let's do that. Let's say my goal in my presentation is to back up my oral presentation to my classmates and my teacher about what is an ecoregion, what is population density, and then highlight a certain zone around the world. It doesn't have to be India, Nepal. It could be Texas. That's my goal. I just really want to have 2 slides, if you will, in my presentation, one for the globe and one for my region of choice. We'll keep it real simple. Okay? So create presentation. Think of this as PowerPoint meets mapping. Don't overthink it. It's not going to be really fancy. It's got less capabilities than a story map, but it's easier to create. It's faster, and it might work for some of the things that you want to do. Notice to the left of the map, you almost don't need me, folks. You've got an add capability where you can create a new slide. So mine, I'm going to first zoom out to the world. I love it. You can change the base map if you want. When you're happy with slide 1, go ahead and, yep, if that's your, you could set it to current if you've zoomed out to where you want it. You can always change things later. When you're happy with your slides, go ahead and save, and then play it. I mapped it my way. That was so bad. Yep, let me just play this. And once I play this, I'm going to go back to the edit mode. So let's say I'm presenting this to my classmates. I'm going to say, hey, we're going to talk about what an ecoregion is. And this is what an ecoregion is. It's a zone of similar climate, vegetation, plants, animals, and the world is filled with a few hundred of these ecoregions. They are a subset of a biome. And then I go to slide 2. Here's the population density in the India-Nepal region. I've got a lot of population density, high population density on the India side and very little on the north of the Nepal on the China side. And the reason is because there are different ecoregions, all influenced by the Himalayas being a major stopping point for any moisture going north of them. And notice how I have the pop-up coming up automatically because that's the way I set the slide. In my slide list, let me move the zoom window around. Notice I've got 3 slides. I can jump to any one of those. But it's live. It's part of your web mapping system. So you can say, what if someone said, well, I want to look at Texas now. You're not it's not like a static slide like in PowerPoint. You can say, oh, okay, let's go over to West Texas. And what's the ecoregion there? It's shrub and semi-shrub, semi-deserts, and deserts of continental climate. Same thing with northern Chihuahua, right? But once we get over to the west, we've got dry steppes and shrub. And if you get northwest of you, it's a different ecoregion entirely. So you have, yes, slides. I hate to call them slides because they're not static, but you have that as a starting point for a presentation, okay? Let's go back to the edit mode. Yes.
That's okay. Yeah, it's a follow-up to the question that has been asked. Can you repeat the process of creating a presentation? Just quickly go through it again.
Right. Step 1 was in the upper right, there was create presentation. And you don't have tons of tools. You basically have to the left of the map, the add, create a new slide. You can delete slides. You can duplicate the slides. I mean, that's pretty much it. And you've got a couple options here whether you can automatically go through these, or you can set it to a presentation, like if you're at a science fair or something and you want to automatically run this thing. So you can have a timer on that. But that's pretty much it. It takes a little while to get used to, so I'll give you a few moments to tinker with the presentation mode. Let me show you what I've got. Would love to see what you have, but alas, difficult for me to see what you've got looking over your shoulders. But right now I've got 4 slides in my presentation. Slide 1 is my introduction to world ecoregions and population density. Slide 2 is the focus on India and Nepal with the population density layer turned on. Slide 3 is my ecoregions of that part of the world with a pop-up that shows one of the ecoregions. And then I just added slide 4, which is El Paso del Norte and the ecoregions. And notice I changed the base map on this last one. I changed the base map to a satellite image. So that's what I've got in my presentation. I'm sure yours are even better. Let's talk about one final thing before we move on, folks. Where is this thing stored? Yep, it's in your ArcGIS Online account. So if I go to the tab in my browser, one note about tabs in browsers. I think it's important for you to cultivate this whole attitude of students being organized. That's what one of the things that GIS allows us to do as educators. You know, you've gone over to students' work and you peer over their shoulder and they've got their data, their files scattered all over the place, and they've got them named with these weird names. And you have no idea what's where, and after a while they have no idea what's where. So GIS already has enough moving parts to it. Don't make it more complicated by not being organized. A part of that is knowing what you're editing in which tab. So if you're in an edit mode, like we were editing our presentation a moment ago, you don't want to be doing that in more than one tab, right? Because as you know, a lot of these things are auto-saved. Some of them you have to click on a save button to save it. And you're going to get into a little bit of funky versioning issues if you've saved it in one tab and the other tab is still in edit mode. Does that make sense? So oftentimes, like a lot of things on the computer, you have to learn the hard way. In other words, the students might say to you, "Oh, I closed the tab and I didn't save it. Everything I did in the last 20 minutes is toast. It's lost." And you'll say, "Yep, you need to save, and you need to save often, and you need to be organized about your work." So I just wanted to mention that. It's great to have these tabs in these browsers. You just need to manage what you're doing in each tab. Okay. In my edit mode of my ecoregions and population density map, what I have is a home button. I think you looked at this when I wasn't with you part of yesterday. That home tool allows you to look at different things inside your organizational subscription. Right, folks? One of the choices in there is content. So if I go to home and content, you're going to be in your whatever organizational account you're using at the moment. You do have the capability of having folders on the left side, just like you do on your local drive and just like you do in Google Drive and some other places online. I saved my ecoregions and population map in just the root folder. I did not put it in a folder on the left. At some point, I probably should do that. But notice that I've got an ecoregions, population density, and imagery of the world, UTEP, EPISD. That's the map I just saved, correct? Notice that underneath it, I have the story map of the Sustainable Campus Initiative that we made a half an hour ago or an hour ago. So you've got the content that you've created inside your ArcGIS Online account. All good? Okay, you knew all that stuff, but it's a nice reminder, hopefully. The thing to point out here is that you notice that you have a web map of your ecoregions and population density. Where's the presentation? It's inside the web map. It's not stored as a separate item. Yeah, so I just wanted to make sure you knew that. If you go back into your map, notice you've got this is the metadata page, remember? The page that gives you a little bit of information about your map. In my case, I've got 2 layers in there. I've got a base map. I've got a thumbnail that I could change. It's got my name in there, how many people have viewed it, blah, blah, blah. But notice on the right side, there is an open presentation and an edit presentation now that you didn't have 10 minutes ago before you made this thing. So there's 2 things to point out here, not to get too geeky, but I wanted you to see what was behind the scenes. Number 1, the presentation is stored as part of your map. It's not stored as a separate item in your content. The second thing is that because of that, that means that every map can only have 1 presentation. Okay? You can make a copy and make another presentation in your copied map, but each map can only have 1 presentation. So there you have it. You've made a presentation. You can see that it's faster than a story map. It doesn't have as much functionality, but it might be useful for some quick and easy presentations that you want students to build. This one here that I was showing took about 5 minutes to make, is all. Good? How are you folks? I'm not hearing anything over there. Easy stuff? Too easy? Am I going too slow? Cool. I love these presentations. They're not used all that often, and I always like to include them in my workshops because they're easy to make and they're very powerful, I think. And students at all ages can make these. I mean, I've made them with primary school students many times because it's, as you can see, all you get is a title and then your map content. So it's limited functionality, but could be a very nice backup to the ultimate goal, which of course is to foster oral and presentation skills. Very good. Muy bien.
Okay.
Yes.
A couple of
Yeah, so if they get their school accounts before 7 July, they can use, I'll type it into the chat box, something called the AGO Assistant. And that'll allow you to transfer your content from one organizational account to another. It's an online tool. Your first point, though, about web connectivity, I'm not quite following, but I will say that I almost always test out, if I can, whatever activity I'm doing in the classroom where I'm going to be teaching, if possible. Even if you have to come in there, you know, a little bit early, because, you know, different schools have different bandwidths. It seems like it's really good in Dr. O's school. But if you're in a place where I want to test out some of these, make sure that it'll support, 20 students all doing the same kind of work on your IT bandwidth there.
Okay, perfectly.
Yep. Okay. Sure.
I think something along the line of clearing the cache.
That may be fine if that helps your anything that you can do to help your browser speed up. Great. It's not such a big issue now, but a couple years ago when we first started doing bring your own device type of workshops, some educators would come there with all kinds of add-ins on their browsers. Ask Jeeves and other things. And these things tend to slow down the browser. So whatever you can do to get stuff off of there that will just let you, as quickly as possible, access and use these web maps, I think the better. And along those lines, your clearing cache idea is a good one, as long as you've saved, right? If you don't have any active edit sessions going, in other words, you're not editing a story map and you're not editing a web map, make sure you save all those before you clear.
Dr. Kursky, this is Maria. I had a quick question.
Hey, Maria.
If you create a story map, how is it possible to then link that story map to open on a regular web page rather?
Oh, yeah.
To come back and
yeah. So in my story maps set of slides, let me go into that just briefly here. So it's the telling your story with the Esri story maps. That one. If we go there, this is the slide that we were looking at the other day, or sorry, about an hour ago when we were working through the story map that we were building. Remember, we were making the Esri Sustainable Campus story map. And so inside there, I have a whole set of slides, but one of them is exactly what you're getting at. And that is, let's see, it's page 20-something-ish, 24, I believe. Anyway, take a look at this Anchorage Urban Bears one. This is just an example, but it's the Alaska Department of Fish and Game. So this could be your school district page, your Weebly page, your Google Sites page. In here is a story map of Anchorage Urban Bears. Notice the top URL. Are you guys seeing this? It's alaska.gov. So, but inside there, they have their story map embedded. It's actually a really interesting story map because it's all about the behaviors of these urban bears and trying to get the community to understand what these bears do. And also, it gives you, on a techie note, the capability of thinking about, ooh, in my pop-ups, I'm not just confined to photos and text. I can actually pop up a video. So as you can see here, these are videos from the cameras on the bears. Yeah, I'll leave that to the professionals to put those cameras on. No, thank you. But it's very interesting to be able to use these, and this might be an interesting story map that you might be able to use in terms of human animal interaction and why we need to understand the animals. Obviously, it's not these kinds of animals in your community or in mine, but it's coyotes. What do we do when we see coyotes or certain kinds of snakes or whatever? So this could be a nice one. But the techie point, though, I think you're bringing up is, yeah, you can. When you make a story map, you get an embed code, and you can copy that embed code and put that code inside your URL, inside your code for your web page. Does that make sense?
yes, thank you.
Yeah, good question. I love doing this kind of thing, embed them in a larger web page. All right, very good. All right, super.
Yeah, I think they're happy.
Excellent. Well, let's then go to our outline for today. We're on our last activity now, and that is number 36, practical exercise 20. And it is global plate tectonics. The reason why we wanted to include that is we realize that not all of you are teaching this topic. But again, think of the concepts that you are going into here. The fact that you've got a map and you've got a table behind the map, and you can symbolize things differently. You can sort the table differently. You can do analysis on the map. So those are the main points that we want to get across, not so much where earthquakes are in relationship to volcanoes, although that's very interesting, especially for you earth science type geography teachers. But if I click on that Examine Global Plate Tectonics map, it will pop up with, as you probably would expect, plate boundaries, earthquakes, volcanoes, and continental outlines. I'll pause while you pull that map up.
Yeah, I think they're good.
Great.
They're there. Let's move on.
Are you folks logged in the upper right? Nice. We'll be able to do a little bit more when you're when you're logged in. Great. Let's do a couple of things that are really core to working with geospatial technology. First of all, if I click off of these, remember I'm in the Content tab. If I go to World Volcanoes, and let's go to that Open or Show Table button. It looks like a little waffle. It looks like a little spreadsheet. Go ahead and open that. You've got a lot of volcanoes in there, correct? You've got how many? Okay, 1,546. Every volcano has a row in the table. This is the I part of GIS. And just like you do with a spreadsheet, a regular spreadsheet that's not mappable, you can go to elevation, for example, and I want to sort descending. So if I go to elevation, sort descending, I'm going to see the highest volcano according to this data set. So I'm going to click on that, and it says features 1546 selected 1. Everybody's good with that? So I went to volcanoes, I opened the table, and then I sorted descending on elevation. So I have 1 selected. It's on the map somewhere, and I want to find out where it is. So if I go to the options in the upper right of the table, tell me what you would do so that you could see it on the map. You could, there it is. But if I want to see it on the map, yep, center on selection, awesome. So there it is, it's in the center of your map. It's the one that's got a cyan colored box around it. And now you can just use the plus sign to zoom in on it. So according to this data set, that's the highest volcano in the world. What countries is it on the border of?
Chile and Argentina.
Excellent. Gosh, I'm going to quickly change the base map and take a look at that to imagery maybe. Zoom way in on that thing. Oh, wow, interesting. Some snow there at the time the image was taken and so on. Okay, so now as we did a couple of hours ago, actually yesterday's workshop, I'm going to show all records. But what about the idea of teaching some current events with these tools. Well, what about fuego in Guatemala? Not too long ago, sadly killed people, right, in Guatemala. So that's the Fuego volcano erupting on June 3, about 3 weeks ago. What if I wanted to look at that in my map? So I go back to my map. We've already looked at the table. There are types of volcanoes in here. There's also the name. So we could sort, but there's 1,500 of them. Is there a faster way to do it? Yes, there is. You could sort ascending and then scroll all the way down to F and find it. But another way to do it, a faster way to do it, would be to go to this filter button. Now, thinking about yesterday afternoon, remember when we looked at the Sentinel-2 satellite imagery and we looked at Kilauea? We filtered it on date. So we wanted to see the satellite image on a specific date. It was May 23. Here, we want to filter it on the volcano Fuego in Guatemala. So I'm going to filter. You tell me what needs to go into the box here, this expression box. Okay, name. So you got to know a little bit about your data and how it's structured. And we know that name is Fuego, right? So I'm going to type in Fuego there. I'm going to apply the filter. And so I've got one feature. And it's on the map in a box that's colored in cyan. That way I can zoom in on it with the plus sign. And there it is. So you could do things at this point about, looking at surrounding towns, looking at the terrain, and you could pull up the population density around there, etc. I'm just curious what the base map looks like in the satellite image. Oh yeah, look at that. There's another volcano not too far away from there. So if we show all records now, how do we do that? It's only showing me one. How do I get back to everything? How do I see all of my volcanoes?
Clear selection on your drop-down menu.
There's only one thing selected. Let me clear. Still only showing me one record. Good thought, though.
Go back to the filter.
Ah, good. You have to clear the filter. Remove filter. Now you've got all the volcanoes back. And now you could click on that one out to the east and see that it's agua. I don't know why a volcano would be called water, but interesting. So that's pretty close to Fuego. And there's another one just to the north, Acatenango. But the scary thing is that these are really close to a major urban center, right? Look at this city that's not far away. How far is it away? You've got a measure tool, you could measure it. Lots of volcanoes right here. Okay. So we've done a couple things. We've looked at the table. Let's do this. I'm going to get rid of the table for the moment. I'm going to click on the last 30 days of earthquakes. What if I wanted to bookmark this so I can come back to it later? Couldn't I say Guatemala right there under bookmarks, and that way I'd be able to come back to it later on. So one of the powerful things about using these web-based tools, folks, is that you can analyze real-time or near real-time information. Stream flow from a stream down, like what is the Rio Grande looking at right now in terms of river flow? What is the current state of wildfires? What is the earthquakes in the last 30 days, which is exactly what I'm mapping here. And if you pop up the legend, you can see that right now we're mapping on magnitude. So in the same way that we sorted the table and found out where the highest volcano was, I'm going to turn you loose for a minute or so and have you tell me where the biggest earthquake in the last 30 days was, and whether it's in the ocean or on land. And if it's in the ocean, how far was it from the land? And if it's underneath the land, what country was it in? The biggest earthquake in the last 30 days, according to this data set. I'll let you go do that.
Hi, Dr. K.
Yes, sir.
Yeah, I think they are ready for you.
Wow, they're so fast.
Yeah.
Folks, tell me where the largest earthquake was in the last 30 days. Ah, yes.
And I know I'm right.
And what was the magnitude?
1.1.
Okay. And is it on land or water?
Right next to the land. It's right off the coast.
Okay. Anybody want to disagree with that?
No, it's actually, no, I zoomed in. I disagree with myself. It's on water. It's water.
Yep. So you could bring this back to the why should we care about this and why should we teach about this? Pose this question to your students.
You have to zoom in even more.
Pose this question. Yeah, pose this question to your students. Well, if it's over water or underwater, why should we care about it? It's no big deal, right? If it's in the water. And hopefully your students would say,
Because of tsunamis like the one in Indonesia.
Ah, good. So if this was part of your unit on natural hazards, for example, you could get them thinking about, okay, this is only a short distance, right, from this particular town and this particular part of what you say, Vanuatu? Yep, so that's all part of the country of Vanuatu, northeast of Australia. Really close to the plate boundary, as you can see. So lots of earthquakes there, part of that whole ring of fire around the Pacific. Exactly what's going on. Now, let's do something else. We've mapped the earthquakes, and by the way, being critical of the data as we are, how did I get that earthquake data in there? It's from the USGS Earthquake Center. And what I did was I went to the spreadsheets, as you can see here, and there are earthquake feeds in spreadsheet format. So I went down to this last 30 days, magnitude 4.5 and above, and I added that to my map. We could have looked at all the ones above 1.0, above 2.5, but I chose above 4.5 because I wanted to keep it fairly small. This is where it comes back to your bandwidth situation. You know, just because you can look at every single earthquake in the last 30 days that are all earthquakes, that's a lot of earthquakes. The Earth is a dynamic planet, right? There's something happening every day. But I chose to keep it fairly small just so we'd have success with that. So back on our map.
It looks okay.
Yes. There's technically no limit. However, you're on the web. So you need to be sensitive to, just because you can map every single water well in Texas, that doesn't mean you should. Just because you can doesn't mean you should. So you'll have to be a bit sensitive to the fact that you're slinging these data sets around on the web. Now, with this many earthquakes, it's actually pretty responsive, right? I've only got 403 in here.
Right.
But you've got, what, 20 teachers in the room, and you're all looking at 400 earthquakes. If I had downloaded or streamed in, is more appropriate, into this map 20,000 earthquakes, and you've got 20 educators or 20 students all zooming and panning on 20,000 earthquakes, you're definitely gonna have some sluggishness, even if you're at a top-notch place like Dr. O's school.
Okay.
Yeah. So in terms of the data that the students collect, no problem there, because even if they are the best students in the world, they're not going to be collecting tens and tens of thousands of points. They're going to be collecting 50 trees or 50 intersections where there's pedestrians, or 50 pieces of trash, or, you know what I mean? They're going to 50 observations about the weather.
Okay, cool. We are good. Please go ahead.
All right. You folks are great. You just want to keep moving on. I love it. Let's map, instead of magnitude, let's map the depth. So I want to find out, since I have these different plate boundaries, and let's say this is part of my unit on plate tectonics, I don't have all of these created equal, right? So in these plate boundaries, I've got some transform boundaries like the San Andreas. I've got these ridges like mid-ocean ridges, right, where the plates are going away from each other. I've got converging, where the plates are actually moving toward each other. And then I also have diffuse, where it's sort of ill-defined. So my hypothesis, based on what my teacher was just talking to me about yesterday, is that on these converging or subduction zones, I'm going to have deeper earthquakes. So you might show them that classic, from a textbook or online, the plates moving into each other, that cutaway diagram of the Earth's crust. So my hypothesis is that along these converging boundaries, for example, South America, I'm going to have deeper earthquakes. But to support my hypothesis, I need to map it. We have been mapping on the last 30 days, 4.5 and above, by magnitude. You tell me, how do we map by depth? Yeah, it's part of your data. You can't do it unless it's part of your data set, and it is. It's depth in kilometers below the surface. So in that table, you can see there are some mighty deep earthquakes, hundreds of kilometers deep. How do I make a map that shows me a bigger symbol for the deeper earthquakes and a smaller symbol for the shallower earthquakes?
Did you add layer from file?
It's already in your map. You don't need to add anything.
Okay. All right. So.
Good thought, though. If you didn't have it, you'd have to add it, sure, but it's already here. You could sort the table and zoom in on the deepest earthquake, sure, but actually what I want to do is I want to change how the earthquakes are displayed on the map, the style that they're displayed at. Right, we want to change. Exactly, so you're right on. Yeah, what's your name? Hi, Ms. Valles. Awesome. Hey, good to have you here. So Ms. Valles is exactly right. If you go to change the style underneath the earthquake data, it's going to allow you to change the attribute or the field name in the table. We've been mapping magnitude, but what do we want to do now? I did. I went to content. Underneath the last 30 days of earthquakes, there's a change style button. And right now we're mapping magnitude, but we want to map what? Depth, exactly. Yep, and there's depth right there. Now to default, this is how this, behind the scenes, it's running something called smart mapping, where it kind of anticipates what you want to do and it symbolizes it based on what it thinks you want to do. You can always override that. So for example, if I don't want 5 categories of depth, I can change that. We'll do that in a moment, perhaps. But let's just say done. Now I've got, if I pop up the legend there, now I've got depth instead of magnitude. So I can see that on the western edge of South America, I do have some deeper earthquakes, but especially over here in this subduction zone where we were looking at Vanuatu a moment ago, there's some really deep earthquakes in there, aren't there? That's right along the, close to the Tonga Trench. And then there's some in Southeast Asia that are super deep. Like, look at this one, June 22, that was just yesterday. 652 kilometers down. So again, think outside the box here a bit, folks. You're gaining some key skills in using geotechnologies. What if this was cities of the world? What if this was historical sites in Texas? You're using the same tools on any of those other data sets. You're going to the table, you're changing the symbology, you're sorting, you're filtering. These are core tools that you're going to come back to time and time again. It may seem a little puzzling now, but you're going to keep coming back to changing the symbols, opening the table, clicking on and clicking off layers. That's really what you're going to be doing. Questions, comments? Good point. Working with tables, I think, is a key skill in not just GIS, but outside of GIS, knowing how to build a database. And what I found, even with my university students, is that they are very tech savvy in many respects, right? They can download an app, they can do lots of things on their phone, they can image manipulate, they can run Photoshop, etc. But what I've often found is that some of these core GIS skills, like working with a spreadsheet, which may have been pretty common 15 years ago, they oftentimes have no idea how to do that. So I think what you're saying is very important, that you need to label your fields in something, for example, that makes sense. And if you want a numeric field, for example, height of tree on your campus, or amount of rain in the last 24 hours, or something that's numeric like that, you can't put a letter in that field, right? So if this was, for example, we have depth on this earthquake data set that I'm showing you right now. If the students created their own table with, let's say that was tree height, let's say it's in meters, and they have 7.5, 4.3, etc. They can't put 7.5 m in that field, right? Because then this is just a computer. It'll interpret that as text, and you won't be able to sort it. You won't be able to symbolize it as graduated color or graduated symbol. Does that make sense? Indeed. Yeah, and that's where, I know you're going to go into this later, that's where Survey 123 comes in. Because with Survey 123, you're setting up a form, and the students can go outside and use your form, and they, instead of typing in red, blue, tree height, etc., tree species, they're actually picking it from a menu that you set up. So if you say red, blue, green, etc., they're picking it rather than typing it. So you've got data consistency there. Exactly.
Yeah, thanks for that.
Absolutely. All right, one last thing before we leave the earthquake activity. I just wanted to gently introduce you to this whole idea of doing analysis. Now, one might argue that we've already been analyzing things spatially, and that's true. In some ways we have. But you have some quantitative analytical tools inside this toolbox that I think it's worth spending about 5 minutes on. Because you're logged in, you should have an analysis button to the upper left of the map. You folks have that? So you have an analysis button to the upper left of the map, correct? Sorry?
We are good to go.
And they have an analysis button to the upper left of the map.
Yes, except a few folks who are, just one person who is sorting it out. But I think we can proceed at this point.
Okay.
We'll do the catching up.
Yeah, and you're working with those people that might not have an analysis button. They must be
Yes, exactly.
logged into a different account without the privileges. Yeah.
Exactly.
No worries.
That's why I want to change, especially I would say.
Okay. So if you have an analysis button, folks, I just want to have a gentle introduction to what these analysis tools will allow you to do. Let's say our question is, I want to find out how many volcanoes are within X distance of El Paso. I didn't realize there were volcanoes near El Paso, but if we zoom in there, as you know, there are a few up in New Mexico. Okay. So let's say we set a distance of 500 miles or 1,000 miles or kilometers, if you'd rather use that. We need to do that with analysis. We can count, oh, this is probably less than 1,000 miles from El Paso, etc. But we don't have to just guess. We can actually use the analysis tools to find out for sure. And just like other activities today, think outside this particular theme. I want to find out how many cities are within 100 miles of the coast. I want to find out how many cities are within 100 miles of all of the hurricanes that have blazed through in the last 10 years. I want to count the number of neighborhoods that, like we were talking about yesterday, that have a certain income level of this and a certain median age of this. That's the kind of thing you can do with these tools. So that said, let's go ahead and do that. In order to do that, we need to click on the analysis tools in a moment. But first, in the upper right, I'm going to type in El Paso. Okay. And the search result there, let's go ahead and add it to map notes. See where it says add to map notes? That places a place mark on El Paso that we can then use for analysis. Now this map note actually is pretty powerful. So for example, if we go now to the analysis tool, what if we did the following? What if we look at the different things that we can do? There's about 40 analysis tools in here. Really interesting. This is a whole different workshop. But just a little exposure to this. Let's go under Find Locations and do one thing that's outside the earthquake theme, because I think it's wonderful. Find Locations, Trace Downstream. You know where I'm going. It's the classic, if I poured a jug of water out in El Paso, where's it going to flow? Now, it's pretty obvious where you are. It's going to flow down the what? Where's it going to flow? Okay, down to, what's the major river there? Awesome. So what's nice about these tools is it guides you as a step-by-step operation. So in this trace downstream, and where was the trace downstream? It was analysis, find locations, trace downstream. So analysis, find locations, trace downstream. The point features used as a starting location for the downstream trace. What is the point location? The point location is my map note that I just dropped on El Paso, right? And then number two, my trace downstream settings. How far do you want to take this? I'm going to take it 1,000 miles. Maximum distance, 1,000 miles. I'm not going to split anything, so I'm going to leave that one blank. I'm not going to clip the output. I'm just going to call it trace downstream from El Paso. This bottom button here is really important. Use current map extent. Notice that I'm just looking at El Paso right now. So if I cut it off at this map extent, it's going to go to 30 miles downstream and quit. So I'm going to uncheck use current map extent, and then I'm going to go ahead and run analysis. So if you're teaching students about water and why it matters and where it comes from and where it goes, this could be a very quick hands-on activity where they drop that point on El Paso and they compute, oh, it's flowing down the river there, but how does it get to the river from where my campus is, for example, right now? You could also do it for a place in Colorado, a place in Alberta, a place in another part of the world. Now, just like you did with earthquakes, if you expand the trace downstream, you can change the style under options and make that line a bit thicker if you want to, totally optional. But I think that line's too thin, so I'm going to make it a thicker blue, okay? I'm going to say done. So I've just changed the style just like you did with earthquakes. And now I've got, as you would expect, ooh, 1,000 miles. It would just quit right there. Interesting, because it's following every single little meander. I should have bumped it up to a higher distance. But does that make sense? Interesting. Yes.
Yeah, if you folks, can you repeat this particular operation that you've done, tracing downstream?
Sure. Interestingly, if I just want to look at this in fine detail. If I change the base map to something like OpenStreetMap, notice where I dropped my point. I dropped it pretty much in downtown. It looks like it flows kind of due south and it kind of meanders around and then it gets to the river. So it depends on where I drop my point. Okay, I'm going to do it again, and I'm going to do it in a different location just for fun. This time I'm going to go to where I am, Denver. Okay. I'm going to add to map notes. So now I've got a map note on Denver. I'm actually going to back to El Paso for a moment. And I'm going to delete that one. Why am I doing that? I don't want to run a trace on El Paso again. I want to run it on Denver. Okay. So analysis, find locations, trace downstream. So analysis, find locations, trace downstream. And number one, your point features used as the starting location is your map nodes. In my case, my one map node is Denver. Maximum distance, if I'm going to go all the way from Denver to wherever it's going to flow, I'm going to put a big number in there, maybe 3,000 miles. I'm also going to uncheck the use current map extent. And then I'm going to run it. So analysis of service names map nodes traced already exists, so I have to rename it. So I'm going to go back to analysis, find locations, trace downstream, and my point is my Denver 3,000 miles, my map layer name, trace from Denver, uncheck current map extent, run analysis. You see that it gave me an error because I already had a layer called plain old trace. It has to be a unique name. Now this is where you're processing this on the web. So, you know, patience is a good thing. You don't want to just like, oh, it's not working, it's not working. It's spinning, it's got to process all that up in the cloud, and then it's going to return a layer and display it in your map. So now my one from Denver is radically different from, it's still ending up in the Gulf of Mexico, but I've got to go down the, in my case, the South Platte, all the way to the Platte, and then at just south of Omaha, it's going to go down the Missouri, and then the Mississippi, right? So that's my trace. One last thing on that particular water-based unit. Someone mentioned adding data before. One of the powerful data sets is if you add data using the add button in the upper left, and you add and you search for layers, one of my favorite layers, and this is all up in the cloud, is World Hydro. World Hydro, and see, I'm not going to look at my content. I'm going to add, search for layers. It's not my content, it's actually ArcGIS Online. See where it's a drop down? Add content, ArcGIS Online, World Hydro, and it's the second choice down, World Hydro Reference Overlay, and add to map. Here's why I love this, because look, now you've got a scalable set of rivers. And now thinking about your elementary teachers in the room right now, let's turn off some of these other layers. If I'm teaching third grade and I want to show them major rivers of the world, this is all I need, right? I've got the Mississippi, the Missouri, the Colorado, the Rio Grande. I've got the Amazon, the Nile. I've got a very simple map showing just rivers and just countries. Does that make sense? So a lot of times elementary teachers and even some other teachers will say, hey, Joseph, I just want a map of this and this, and my textbook doesn't have it. I can't find it online. You can make one like this and then save it. And now all you've got is rivers and countries. That's all you've got. So that's, to me, a really nice teaching tool. Now, as I zoom in, though, I get more detail. I get more rivers. And if I zoom in even more, tell me what this is. Tell me what these little dashed boundaries are. Right.
I think they're watersheds. That's what I think those brown dotted lines are.
Oh, you folks are so good. And they're scalable, just like a lot of other data that we've looked at. So at this scale, you can see the Rio Grande watershed that goes all the way along the boundary of the river, of course, and then up into my state, Colorado, because we've got some drainage that goes into the Rio Grande as it rises in Colorado. And then you've got this one right here that drains most of the rest of Texas, right, into these other rivers flowing into the Gulf. The nice thing is that if you zoom in even farther, you're going to see some additional sub-watershed boundaries. So for example, just north of El Paso, right, you've got that ridge. And so north of El Paso, it's actually flowing into this watershed up in New Mexico. Right. Fascinating. And then you've got the lower Pecos, you've got even the watershed names. I love this stuff. Really interesting. Up by me, I've got a major watershed boundary at the Continental Divide, right, that runs through the middle of Colorado. And so this area on the west side goes to the Pacific, this area on the east side goes to the Gulf of Mexico or directly over to the Atlantic. So really interesting. All right, one more analysis thing before we close, and that was back on our earthquake data. Volcanoes, so on. You ready to go to that last step?
Yes.
All right. Very good. All right, cool. So I need to drop a point on El Paso. How do I do that? I type in El Paso in the search box, and I'm going to add to map notes. There it is. Great. I want to make sure I don't still have one on Denver. So I'm going to go to this one, edit, and I'm going to take it out. Delete. It's gone. Okay. Now I have a map note on El Paso. I am going to just have my world volcanoes on and my map note for El Paso, and that's it. Can I change the symbology for volcanoes if I wanted to? Those are awfully small triangles. Yeah, I could change them. I could just bump up the size if you wanted to. I'm not going to spend time doing that, but you could. You could change the size of those things. Sure. All right. What I want to do is count how many volcanoes are within, what do we say, 1,000 miles of El Paso. Great. So analysis. First, we need to draw a buffer of 1,000 miles around El Paso. So it's use proximity, create buffers. So analysis, use proximity, create buffers. You folks tell me, what is the layer containing the features to buffer? We're going to draw, our question is, we're going to draw a buffer around El Paso, and we're going to count the number of volcanoes inside that 1,000-mile buffer. So the layer containing the features to buffer, we're actually going to buffer our map notes, which is basically the point we have on El Paso. Okay. Now you don't have to use 1,000 miles. Feel free to use another number. My buffer size is going to be 1,000 miles. And my resulting layer name, I'm going to call it 1,000-mile buffer El Paso. And either zoom out and click the button that says use current map extent, or unclick the button, and it doesn't matter where you're zoomed. What's the shape of this going to be? I always like to ask the students, what is the shape of a buffer around a point? Okay, so here's our 1,000-mile buffer around El Paso. Don't just accept it just because it's done. Use the measure tool and verify. So if I click in El Paso and I draw out to the edge of this circle, it's 1,000 miles. Depends on where I click, of course. But I like students to verify when they do these analysis steps to make sure they understand it's truly giving them what they think they are going to get. So a buffer around a stream would be a puffy polygon, wouldn't it? A riparian zone around a stream. A buffer around a state is going to be that state plus a frame around it. And a buffer around a point is basically going to be, depending on the map projection you're using, some sort of circle or oval. Okay, that's step one. Step two now, we need to count how many how many volcanoes are within this buffer, right? And we don't have to do the following. We don't have to say 1, 2, 3, 4. No, we can do it in a more rigorous, quantitative way. You guys have your buffer around your El Paso? There's other kinds of buffers that you can make, just FYI. You could do driving distance. You could do walk distance from your school. Within 5, 10, 15 minutes from your school, how far could you walk? How far could you drive, etc. And as you know, those will not be circles, right? Because those will be based on speeds along streets. They'll be based on the street pattern, etc. So I would highly encourage you to do one of those. You know, where did students walk or drive or take the bus from to get to their school? All right, so last step, one more analysis step. We're going to summarize data this time. Analysis, summarize data. Let's say you didn't know what these things did. You can actually click on the identify button over there and you get a little information for each one of these. So I'm going to summarize data and aggregate points. Or I could join, no. I'm going to go to summarize data, either aggregate points or summarize within. I might as well go to summarize within. So analysis, summarize data, summarize within. Let's do that. And step number one, choose an area layer to summarize other features within its boundaries. What's our area? Our 1,000-mile buffer, very good. And number two, the layer that we want to summarize. We want to summarize volcanoes, don't we? So world volcanoes. Add statistics. Do we want any statistics like a sum or a sum might be nice. We're not going to use anything on number 4. We're not going to group anything. We're going to keep it pretty simple. The layer name that results should be something that's intuitive that you'll be able to come back to. So we're going to say volcanoes sum within 1,000 miles El Paso, something like that. Great. I'm liking that. So analysis or summarizing within. I had some bandwidth issues. This time I'm not going to do any fancy things. Oh, really? Okay. Give it another try. Maybe rename it. I ran it the other way with the other tool and I still got 52. I've got two of them with 52 volcanoes. So again, folks, the analysis tools are important and they're powerful, but sort of a mid-level in the swimming pool. I would start with the things that we've done mostly in this workshop: symbolizing, go to the table, open the geo inquiries, open those maps and those lessons, and the other resources that we've got here for you. Does anybody have any major questions about that? So now, one last thing for you math teachers out there. How many total volcanoes did we have?
Oh, I'm sorry, Dr. K, we do have a question. A lot of us keep getting error. We can't actually run the analysis.
Do you have an analysis tool?
Yes, we do, yeah. So we go through all the steps on the process that you walked us through.
Yep.
And when we hit run analysis, we get an error.
And you have permission in your organization to, one of the things to check, just FYI, is if you've got publishing rights in your organization.
I thought I did. I checked my my profile settings.
Yep.
And I'm pretty sure I'm a publisher within my school.
Okay, you probably are. Let me think about that. That's usually the first thing I check. So we'll have to keep chatting about that.
Okay, thanks.
Yeah, that wasn't a very good answer. Sorry, but yeah, it's the publishing rights. It might be the bandwidth, but it seems like it's pretty good right there. Anyway, last thing for you that want to do a little bit of math integration. I know we've got some math educators there. So we had 1,546, right, total volcanoes. In our last analysis, we had 52 within 1,000 miles of El Paso, or whatever distance units you used. So what percentage of the total number of volcanoes around the world were within 1,000 miles of El Paso? 3.3%. So not very many, but it's interesting to look at these maps. Just to the north of you, for example, there is that cinder cone over by Carrizozo, New Mexico. I've gone caving up there. That is a fascinating landscape. You could do some investigation on whether that's actually active or not. This should be the one over by El Malpais in western New Mexico. That is a bunch of lava flows there. Nothing has happened recently. And so what about down in Mexico? What's the closest one? There's a lot on Baja, aren't there? There's one over by Durango. There's a volcanic field. It's from the Holocene, probably not doing anything right now. But of course, there's a bunch down by Mexico City, right, and Puebla and other places down there that have been pretty active in the past, Cotopaxi and others. But nothing really close. I mean, even to that one in New Mexico, it's over 100 miles away. But what if you did the same kind of thing for hurricanes or tornadoes or etc.? Now I've got the tornado tracks in there. So maybe volcanoes is not a big concern, but I'm going to change the base map to this light gray so I can see things better. I see a tornado that's actually happened east of Las Cruces at one point in the past. In 2007, interesting, F0, very minor. But you start going east in Texas, of course, and there's some major tracks. Now, one last thing about data. When you start adding layers, especially important in your part of the world, right, where you're on a national boundary, you got to make sure that when you can, you get some data from Mexico, right? Because it's not just we're looking north of the border, right? You got to look at all parts. I mean, you're a region. It's important to look at north and south. So in this case, I've got the tornadoes layer. It came from NOAA. It came from the U.S. National Oceanic and Atmospheric Administration. Not that they don't have global data, but in this case, if you concluded that there are no tornadoes in Mexico, that's not true. Sure, there's a lot in the central U.S., but there have been some, and you can see that all this data stops at the border. So wherever possible, I would highly encourage you to make sure that if you get a data set, the earthquakes data is global, but let's say we're looking at tornadoes now. There's definitely some tornadoes down in Coahuila and a couple of these other states, right? They're not just north of the border. So it's just a note, again, to be critical of the data and make sure you get some data sets on all sides. Okay, questions about that? All right. Thanks for hanging in there, folks, and for just jumping right in and doing the analysis. Much appreciated, and I salute you all.